Hi students, today's MCQ and the question goes like this. If set A is equal to 2, 5, 6, 8, the elements of the set A, then the relation R has these ordered pairs. That is 2, 5, 5, 2, then 5, 6 and 6, 5. These are the ordered pairs. Then we have to check whether the relation is reflexive, symmetric and transitive and find out the right option. Hope you remember the conditions for the relation to be reflexive, symmetric and transitive. Let us have a quick recap on that. For a relation to be reflexive, all the elements of the considered set A on which the relation is defined should have an ordered pair like this. That is, the relation should have an ordered pair like this, A, A, that is 1, 1, 2, 2, 3, 3, like that. All the elements of the set on which the relation is defined should have such ordered pair. Then it is a reflexive relation. To check the symmetry, if there is an ordered pair like A, B, then B, A should also be there in the relation. Then only the relation is symmetric. And to check the transitivity, if and only if A, B and B, C belongs to relation. That is, if A, B and B, C belongs to the relation, then we should have A, C. We should have an ordered pair whose first element is same as the second element of this ordered pair. Then we can look for an ordered pair A, C in the relation. Then it is a transitive relation. If these two exist and A, C does not belong to the relation, then it is not a transitive relation. So when you say if and only if these two belongs to the relation, we should look for the third ordered pair. If we do not have this second ordered pair like B, C, we may have A, B, and if we don't have B, C, then absence of second ordered pair in the relation makes the relation transitive by default. Please understand. If we have these two, we should have this. If we do not have the second ordered pair, then we don't have to look for the third ordered pair. How do we look for the third ordered pair? We don't know which element this would be, correct? So, absence of the second ordered pair makes the relation transitive by default. So, in two cases, relation becomes transitive. One existence of these two ordered pairs, and if A, C also exists, then it is transitive. Then absence of the second ordered pair also makes the relation transitive. Clear? So let us check the ordered pairs here. We should have had 2, 2, 5, 5, 6, 6 and 8, 8, which we do not have. So 2, 2 does not belong to the relation. So this is not a reflexive relation. To disprove something, you just have to give one example. We don't have to give all the examples. Since it is an MCQ, you don't have to give, just understand that. But let us check for symmetry. Here, option A and option D are eliminated now. Clear? So we'll look for symmetry. 2, 5 exists, 5, 2 also exists. Then 5, 6 exists, that means 6, 5 also belongs to the relation. That means this is a symmetric relation. So our answer is option B. Now, if we were to have an option like symmetric and transitive, then we should look for transitivity. Such options are not given, so we are stopping here. But for your understanding, I am just explaining the transitivity for this relation. I will consider 2, 5 as the first ordered pair. Then I should look for an ordered pair whose first element is 5. You can see we have two such ordered pairs. So I will consider 5, 2. Then we should have 2, 2, which we do not have in the relation. So it is not a transitive relation. We can also consider 5, 6. 2, 5 and 5, 6 as the ordered pairs. Then we should have 2, 6 also for this to be transitive. That also does not exist. So further we are not checking. That means this is not a transitive relation. This is only for your understanding. Hope the things are clear.